Hey guys, I'm Michael, a special tutor here at ATAR Notes. So let's talk about complex numbers in Cartesian and polar form. So if we have a complex number, we can represent that on the complex plane. How far is it in the real direction, say 2, and how far is it in the imaginary direction, say 1. But we can represent that same point in a different way by asking how far is it from the origin, and then at what angle, with angles being measured in the positive direction of the real axis. So with that same point, we can use Pythagoras to work out that it's 5 units from the origin, and we can use some trig to work out that the angle is pi on 6. So we can notate this new way of describing complex numbers with r cis theta form. So for example, this point here would be 5 cis pi on 6. So we can convert between Cartesian form, say this one 2 plus I, and we can convert that into polar form. So we can convert between these different forms of representing complex numbers. So say we can convert Cartesian form into polar form. We can use Pythagoras to work out the r, how far it's going to be from the origin, and then our angle is going to be inverse tan of minus y over x, where y is the y direction, x is the x direction. But keep in mind, you do want to check what quadrant it's in. This will only give you sort of the angle in the first quadrant, so if it's somewhere else you need to modify it to get it in the right quadrant. Then if we're converting polar into Cartesian form, what we can do is just expand cis. So for example, if we have 2 cis pi, for example, in polar form, we can expand that. So cis is cos plus I sine. So we can expand that. So 2, and then in brackets we'll have cos of the angle plus I sine of the angle. And of course we can simplify cos pi and sine pi with exact values. So remember these methods when you're converting between polar and Cartesian form with complex numbers. Thanks for watching.